Hi there, this is Advithi Reddy from ECE department, and here we'll dive into one of Fourier transform property, timescaling. Fourier transform is a mathematical technique that transforms a function of time into a function of frequency. This is done by integrating the function x of t multiplied with e to the power of minus j omega t to the limits of minus infinite to infinite with respect to dt. Basically, scaling is of two types. Now, here we dive into timescaling exclusively. Time scaling is compression or expansion of a signal in time, and after scaling, the original signal will change. If a signal is expanded in time by a quantity of A, then its Fourier transform is compressed in frequency by the same amount. It is shown as x of t when undergoes Fourier transform gives x of omega. Let the original signal be x of t and the change signal be y of t. In time scaling, we multiply the time t with a number alpha which is not equal to 0, and this results in the function x of alpha t that is equal to y of t. There are two cases to this. When mod alpha is greater than 1, then x of alpha t is compressed version of x of t. And when mod alpha is less than 1, x of alpha t is expanded version of x of t. According to the timescaling property of Fourier transform, x of alpha t, when undergoes continuous Fourier transform, gives 1 by mod alpha x of omega by alpha. Let us take a minute to prove this. By the initial definition of Fourier transform, the converted signal function x of omega that equals f of x of t equals integral minus infinite to infinite x of t into e to the power of minus j omega t dt. Now, replace t with alpha t as that is the function we need. It becomes f of x of alpha t equals integral minus infinite to infinite x of alpha t into e to the power of minus j omega t dt. Now take alpha t equals u, then dt equals du by a. Now replace dt and t in the above function, and the function is now with respect to u. F of x of alpha t equals 1 by alpha integral minus infinite to infinite x of u into e to the power of minus j omega by alpha into u du. There are two cases to this. When alpha is greater than 0, then f of x of alpha t equals 1 by alpha into x of omega by alpha. And then there is the other case when alpha is less than 0. Then f of x of alpha t equals minus 1 by alpha into x of minus omega by alpha. This can be generalized to the form f of x of alpha t equals 1 by mod alpha into x of omega by alpha, or can be represented as x of alpha t has its continuous Fourier transform function as 1 by mod alpha into x of omega by alpha. These two images represents two cases of time scaling. In the image A, when there is compression of time, the signal gets expanded, and it is vice versa to the image B. That is, when there is expansion of time, it leads to the signal to compress. Thank you.